Hey everyone, this is the week 8 notes presentation for forces and friction, brought to you by Mrs. Ertl. In an easy way to explain what a force is, it's simply a push or a pull. They can cause an object's motion to change. In other words, they can cause something to accelerate, but they do not always do that. They're measured in newtons in honor of Sir Isaac Newton, who did a lot of experimentation and research and discovered the laws of motion and gravity. And so this unit is named in honor of him. As with velocity and acceleration, forces are vectors. They have a direction. You maybe would know that just by knowing that they push and pull. When you push and pull, you're looking at a certain direction that you're doing that in. What we're going to look at mostly today is how you combine forces. There are very few objects in the world that have just a single force acting on them, and you need to look at all of the forces acting on a single object before you can determine if it will accelerate or change its motion. This combination is called net force, and it really is as simple as adding and looking at the direction that things are moving. So for finding net force, forces are vectors, like it says, so you're going to add them similar to what you did with displacement. I know this year we did it a little bit different, but you are going to look at the direction that the arrow is pointing, and then you're going to decide, is that a positive or is that a negative? And then add them together. So in the first example, where you have 45 newtons, it is pointing towards the right, and towards the right is a positive number. 90 newtons to the right, which is also positive. So I would add a positive 45 and a positive 90 to get a positive 135 newtons. Please remember, you do need to include the positive because that is the direction for your force. If you drop the positive, then you will lose points. It's not a fully correct answer. On the second example, you have 110 newtons pointing towards the right, so that's a positive 110. You have a 35 newtons pointing towards the left, which is a negative 35 newtons. When I combine those, positive 110 plus a negative 35, you would get a positive 75 newtons as your answer. We have terms to measure or to explain whether the forces are what we call balanced or unbalanced. Simply put, balanced forces is where the forces add up to zero. It's like they balance each other out or they cancel each other out. When you have balanced forces, they do not change an object's motion. If an object is sitting still and has balanced forces on it, it continues to sit still. If an object has balanced forces acting on it and it's moving, it continues to move in a straight line at a constant speed. Again, no acceleration. If the net force is anything else, whether it's a positive number or a negative number, or even if it's something tiny like 0.1, these are called unbalanced, and they will always cause an object to accelerate. So they will cause an object to speed up, to slow down, or to turn, and those are called unbalanced. When we put those together, you will, or at least when you go to your assignment for net problems in motion, this is kind of what we're looking at. So we have a picture of two boys pushing a shopping cart. The one boy is pushing with 100 newtons towards the left, and one is pushing with 60 newtons to the left. You do this the same way I just did on the example. I would know that the 100 newtons, if I'm going to combine them to find a net force, the 100 newtons and the 60 newtons are both pointing left. So I would have negative 100 newtons plus negative 60 newtons to get negative 160 newtons. Is it balanced or unbalanced? Based on the terminology that was just defined on the previous slide, these would be unbalanced because only zero is balanced. The third question is, which way is the acceleration? In other words, which way is this cart going to change its motion? And since the net force is to the left or to the negative, sorry, my face is in the way, that's where you would find, that's where you would find the direction of acceleration going to the left or to negative. On another example, we have a tug of war. You have 425 newtons to the left, and you have 425 newtons to the right. When I combine those, again, the left is negative and the right is positive, so I get an overall net force of 0 newtons. This is not north, this is for newtons. Are they balanced or unbalanced? This would be balanced forces because I add them up to 0. The direction of the acceleration, well, if forces are balanced, there will be no acceleration, so I would put none or 0. One last example. Getting a little more complicated here because we have 4 forces acting on this same box. There's a note up in the corner that says compare up and down, compare left and right, doing 2 separate calculations. So when I calculate the net force, up and down, negative 6 newtons down, positive 6 newtons up, gives me a 0 when I add them together. A negative 3 newtons to the left, 20 positive newtons to the right, gives me an overall net force of positive 17. Balanced or unbalanced? Some people would say both, but it really is just unbalanced because it doesn't matter that half of it is balanced. I'm looking at the overall. So overall, this is an unbalanced situation. Which way is it going to go? Well, it's going to go positive or right, always towards whichever force is pushing or pulling the most. So at this point, you would, I expect you to maybe take a break and then go work on the net force and motion assignment. This video will continue, and I will talk about friction in the next few minutes here. So if we are going to talk about friction, friction is also a force, and it is a force that always works opposite to an object's motion or an object's velocity. If you've ever rolled a ball across the floor, you know that something is making it slow down, and that something is friction working in the opposite direction. So this is, the car is moving forward, right, positive. Friction is acting backwards, negative, to the left. So always exactly opposite to the object's motion. There are some types of friction here. Static. Static, not like static electricity, static like unmoving. And a static friction is the type of friction that keeps an object from starting to move. You've maybe noticed that sometimes if I'm pushing something really hard, that's really heavy, it takes more effort to get it going than it does to keep it going. And that difference in how much you have to push is what's called static friction. It resists that change of motion. Sliding. I don't think I have to give you an example of this, but if you need one, this would be what gives you floor burn when you wipe out on the gym floor, or what gives you road rash if you wipe out outside if you're skateboarding. It's how your pencil works, how your eraser works. Sliding friction, 2 solids is sliding over one another. Rolling friction, again, not one that you probably need much explanation of, but rolling friction is anytime something that is round rolls over something flat. So this could be a ball rolling across the ground. It could be ball bearings in a wheel. It could be a wheel rolling. It could be your pencil rolling across the table. All of those would be experiencing rolling friction. Air is a type of friction, often called air resistance instead of air friction. Anytime anything moves through the air. So the leaves blowing in the breeze or your hair blowing in the breeze are experiencing air friction. A parachute falling to the ground is experiencing air friction. Your arm out the window in a car, that push back on your arm, that is a result of air friction or air resistance. And then there is one called viscous, not vicious, spelled differently, viscous friction, where something is moving through water or other type of liquid. So viscous friction would be someone that is swimming, or if you are slipping on a pool deck that is wet, or if you are water skiing. Another one that is viscous friction that we don't often realize is anytime you slip on the snow or the ice. When you step on snow or ice, that pressure melts a small layer and it becomes a liquid. And that's why part of the reason it is so very slippery is that viscous friction is very low, which means it's very easy to slip on. In comparing friction, so which one's hardest and which one is the easiest. I kind of hinted at it already, but static friction is the greatest. It takes the most force, or if you want to like the word effort, to overcome. It requires more force to get this box moving or a big box moving, static friction, than it does to keep it moving in terms of sliding friction. So sliding friction is less than static friction because it's easier to overcome. It requires less effort, less pushing, less pulling. If you think about rollers, so changing it to rolling friction, you'd probably realize that that's going to be even less than sliding friction. At least if you're talking about the same object, it's going to always be less than static friction. If you want to think about, well, what about air friction? If you've ever played air hockey, if you leave the table off, it's sliding friction. If you turn the table on, you are experiencing air friction. And so hopefully realizing that air friction is also going to be less than sliding. And the same with water. Walking on a dry sidewalk versus walking on a wet sidewalk or wet floor, you are more likely to slip when it is wet, and that makes water or viscous friction less than the other ones. So if we go back to this slide, you could kind of argue, not this slide, sorry. If you go back here, you could kind of say that I've listed them in order from most friction to least friction. It's not 100% true when it comes to rolling, air, viscous. You can also combine them. Like viscous friction and rolling friction are combined if you put grease in ball bearings, because grease would be technically the liquid. But static and sliding are definitely more powerful than the other ones. As you, since this is the end of the slideshow, one thing you should realize is that the assignment for this one is just identifying the types of friction. So being able to identify the 5 types of friction in a story. It's called friction questions. It also asks you, how does friction affect motion, and how what actually friction is. So thanks for tuning in, and hopefully this helps you complete your assignments for the week.